Hi, this is Marissa, and today I want to talk about pointers as function arguments. In my previous video, we talked about the basics of pointers, and now we're going to see a little bit more how we can use them. So the objectives for this video are to essentially go over the differences between what's known as pass by value and pass by reference. So when we're talking about both of these, we're going to explain what each function prototype will look like, how are the arguments being passed, and what exactly is happening in memory when we use one over the other. So pass by value means that when we pass arguments to our functions, we're passing the value of the variable, which means we're passing a copy of it. When we pass by reference, all that means is kind of what it sounds like. We're just passing a reference to some variable. So essentially we're passing a pointer as a function argument. So let's first examine pass by value. You're probably familiar with this, but I want to go through the steps of exactly what's happening in memory when we pass variables by value. So here I have my main method, and I have an integer x equals 1, y equals 2, and my goal is to actually swap those values. So I wrote a function, swap. So it's void swap, and that takes in an integer a, an integer b, and it stores a in a temp, stores b in a, and stores temp in b. So hopefully you know how to swap values in a variable. But when I call this function, I pass in x and y, and then I want to print out the values of x and y in main after I call the function. So let's first look at what's happening in main. On the left-hand side is my code. On the right-hand side is my call stack, or the memory set aside for that function. So when I call main, inside of my main call stack in memory, I have a variable x and a variable y. As soon as I call swap and pass in x and y, the swap function is going to have its own call stack. It's going to be separate from main. So what I have access to in swap is completely separate from what I have access to within main, because all the variables here are local to the functions. Okay, so my swap memory is green. And as soon as I call this swap function, the arguments are int a and int b. So that will actually set aside memory for two completely new variables, a and b, inside of my swap call stack. When I'm using this pass by value, so when I call swap and pass in x and y, what happens is a copy of the value stored in x is put into a, and a copy of the value stored in y is put into my new variable b. Again, completely disjoint variables. They're not related anymore at this point as far as we're concerned. Okay, and again, inside swap, I'm on the first line of my function. I say int temp equals a. Nothing new here. That just says, okay, copy the value of a into temp. Now temp stores 1. Then we say a equals b. So copy the value of b into a. And finally, b equals temp. So copy the value of temp into b. Perfect. So now we have swapped the values of a and b inside of our function. A equals 2 now and b equals 1. But as soon as we reach the closing bracket of this function, or a return statement, when this function leaves, what happens? Whoop. All of that memory is popped off the stack and completely destroyed. So we actually don't even know that a and b existed anymore. And when we come back to the printf line in main, what we're left with is our x and y that we didn't touch at all during swap, and so our output is going to be the same as before the function call would have been. So we have x is 1 and y equals 2. Okay, so in summary, with pass by value, we're passing a copy of the variable, which means that the value is not affected outside of the function call. Great. So now let's look at what happens when we use pass by reference, meaning passing in a pointer. So we have still our main method. We have our x equals 1, y equals 2, and now we want to swap, passing in the address of x and the address of y. So down, if we jump and look at our swap function, notice that the arguments to the function have changed. Instead of passing in int a, int b, we're passing in int star pa, which means a pointer to an integer, and int star pb, which means pb points to an integer. So we're passing in 2 pointers now as arguments. So looking again at our call stack for main, or the memory for main, again we have our x and y variables, both in some arbitrary places in memory. And then we get to the line where we call the swap function. So memory is set aside for that function call. And I now have my variables PA and PB. And those are both pointers to integers. Those are my arguments coming in. They take up memory. And when I call the line swap and pass in the address of x and the address of y, so ampersand x comma ampersand y, that's going to find the address of x, put it into the variable PA, find the address of y, put it into the variable PB. And what this has done is now it says that that argument PA that we have access to in our swap function points to the actual memory slot inside of our main function for x. And PB points to the actual memory slot inside of my main function for variable y. So we've set up this little bridge so we can get from our one function memory spots into the other. So they're both sharing x and y. Okay, so let's look now at the first line of the swap function when we say int temp equals the value of PA, or star PA. What we're doing here is we want to find the value of the pointer A. So star PA, that means we follow the pointer along. So we have PA. Where does that point? It points up at x. So we grab that value 1 and copy it into our temp variable down in our green area, our swap memory area. Now 1 is inside of temp. The next line, we say the value of PA equals the value of PB. Our first step then is to find PB, follow that, so dereference it using the star, follow it through, find its value, which is 2. Then we want to find PA, figure out what it's pointing to, which is x essentially, which is 1. And we want to copy the value of PB, which is 2, into the value of PA, which is x's memory slot. So we copy from y into x. And now 2 is in that location. So notice we didn't modify the actual PA variable or the PB variable. Those are still holding the addresses. Because we're following these pointers through, we're actually copying y into x inside of our main memory stack. So going down now to the third line, we say the value of PB equals temp. So here we just take temp and copy it following PB's pointer and copying temp into the slot that PB points to. So we copy 1 all the way up into Y. Okay, and we know what happens when we get to the end of a function. Everything that existed in that function, when we're done with the call, all the memory is cleared up, popped off the stack, and we're done, and it's gone. So if we look here, when we come back into main on the printf line, this is where we left off, notice that we have actually successfully swapped our x and y variables because we were modifying the memory for those variables all along because we were using references. So the output in this case would be x is 2, y is 1, which is what we would expect from a function called swap. And then when we're done, that memory disappears as well. So in summary, when we pass by reference, we pass a reference to the variable instead of the value. So this means that the value is changed outside of the function call, which in this case is what we wanted. Sometimes it might not be what you want. So just make sure you're thinking about it before you're using it.